This is video 32. In this video, we prove that a path assembly which makes a U-turn is pumpable. To obtain this result, we proceed as follow. Firstly, we show that there always exists a dominant tile. By the previous video, this dominant tile belongs to a candidate segment of the fork. Secondly, three cases can occur when we pump this segment. In the first and second cases, this segment is not pumpable. Then, we will show that a new dominant tile with a greater index can be found. In the third and last case, the segment of the fork is pumpable. Moreover, we will show that pumping this segment is equivalent to pump a segment of the path assembly P. Thus the last dominant tile of the path assembly always belongs to a pumpable segment. Consider a path assembly P and a visible candidate segment of P which starts in I1 and ends in I2. The direction of this segment is the vector v. We consider that the path assembly P does a U-turn. We consider the free zone F associated to this candidate segment. In this example, due to space constraints, we consider that the north is on the right. Our first task is to find a dominant tile. Consider the height function associated to the vector v. Consider the maximum height of a tile of P of index I such that this index is greater than the index I1 and such that the tile Pi is to the north of the tile Pi1. In this example, the three blue tiles matches these conditions. The index D is the index of the last of these tiles. Now consider the discrete ray F period V starting in tile PD. Remark that this ray is a subgraph of the free zone. Moreover, the free zone can be split by this ray into F minus and F plus. Now, we consider the following path Q which starts in PD and ends in the translation of PD by vector V. The path Q is also a subgraph of the previous ray. Now, remark that the tile PD is almost a dominant tile. We only need to check that the translation of Q by minus V belongs to F minus. Unfortunately, this is not the case. The translation of the path Q by the vector minus V is not a subgraph of the free zone. We have to refine our reasoning. Consider the previous ray. Now consider the following tiles. All these tiles are north of Pi1. They are all visible from the west and their ordinate is equal to the ordinate of Pi1 plus k times the ordinate of vector V with k a positive integer. Among these tiles, we consider the one of maximum height. Now consider the following modification of the ray. By adding a small loop, we can pass by the previous tile. Moreover, this new hashed path is still a subgraph of the free zone. Now consider this new index D. We will prove that it corresponds to a dominant tile. Consider the part of the ray which starts in tile PD. This hatched ray splits the free zone into F minus and F plus. Consider the following path Q of direction V which starts in PD. In this case, the translation of the path Q by the vector minus V is a subgraph of F minus. Thus the tile PD is a dominant tile. We have found first dominant tile. Now we aim to prove that this tile belongs to a pumpable segment of P or that there exists another dominant tile. We have to study three different cases. Now, we consider the fork F built in the previous videos. This fork is in green. By the previous video, the tile PD is also a tile of the fork. Consider the following candidate segment of the fork which starts in FJ1 and ends in FJ2. The direction of this segment is V and the tile FJ2 is the tile PD. In a first time, we consider the underlying path of this segment and we try to pump it. Consider the extension of this green segment. Remark that it is not a subgraph of F plus. Fortunately, we can apply the result which was proven as an application of the toolbox. The green ray has been modified to fit into the zone F plus. This green ray allows us to find a new dominant tile PD and a new path Q. Note that the index of this new dominant tile is greater than the index of the previous one. Here, the extension of the new path Q splits the free zone into F plus and F minus. Note that the translation of Q by minus V is indeed a subgraph of the zone F minus. Since PD is a new dominant tile, let's start again. Consider a new candidate segment of the fork. we will try again to pump the underlying path of this segment. In this case, the extension of this green segment is a subgraph of the zone F+. Thus, we can tile this infinite path in order to build an infinite path assembly of period V. We are almost done. Now, consider the structure of the candidate segment of the fork. This segment is made of two different arcs A3 and A4. In this case, we are not pumping a segment of the path assembly P. In fact, we are pumping a patchwork of different parts of the path assembly P. Fortunately, the translation of the arc A4 by V is a subgraph of the underlying path of the path assembly P. This means that the green infinite path assembly intersects with the path assembly P after the dominant tile. This intersection can be used to find a new dominant tile PD and a new path Q. The extension of this new path Q splits the free zone into F- and F+. Consider again a new candidate segment of the fork F associated to this new dominant tile. And we pump this new segment again. In this case, the extension of the green segment belongs to F+ and the segment of the fork is made of only one arc. In this case, we are in fact pumping the following segment of P. Thus this dominant tile belongs to a pumpable segment of the path assembly P. We have omitted a lot of details in this part of the proof. They are in the article available online.